Welcome back for Learning Made Easy. So in previous class we had learned about PN junction diode and transistor in a chapter called Semiconductor. So today we can learn about VI characteristic of a PN junction diode. So it is very important to know about VI characteristics of a PN junction diode. So what do you mean by VI characteristics? V means voltage, I means current, and characteristics. So what is voltage current characteristic of a semiconductor diode or a PN junction diode? So we will understand it. To understand it, we have to have a graphical representation showing the x-axis and y-axis. So we will draw that x-axis and y-axis, and I'll show you in this video. So once we have drawn that, so we have to know that how we can represent that diode in the voltage and current characteristic of that PN junction diode. So this diode has two connectivity. So if this is a diode, it has two connectivity. One is called as anode and another is called as cathode. So when you are connecting that diode in a circuit, if the anode part of the diode is connected to the positive terminal of a battery and cathode part of a diode is connected to the negative terminal of a battery, then that PN junction diode is said to be forward biased in the circuit. And if we will connect the anode part of the PN junction diode to the negative terminal of a battery and a cathode part of a diode to the positive terminal of the battery, then that diode is said to be in a reverse bias condition. So in forward bias, what happens, as you increase the voltage at certain level, slowly the current flowing through the diode increases, but at certain peak voltage or which is called as knee voltage, the maximum current starts to flow through the diode. So that is called as peak voltage, or it is also called as a knee voltage in forward bias condition. So mainly it is called as knee voltage. At that voltage, maximum current starts to flow through the diode, or it is also called as peak voltage. When it reaches certain voltage, maximum current starts to flow through the diode. Next, in a reverse bias condition, what happens? Even though that diode is connected in a reverse condition, residual currents is flowing through that diode. So in y-axis we will show that even the voltage is increasing, the current remains the same. As you increase the voltage, the current remains the same to a certain level. As soon as it reaches voltage, which is also called as the reverse breakdown voltage, maximum current starts to flow. So this is called as a reverse breakdown voltage in a reverse bias condition. And in forward bias condition, we called it as a knee voltage at which maximum current starts to flow, knee voltage or a peak voltage we can call it, at which maximum current starts to flow. So this is the voltage current characteristic of a PN junction diode when it is connected in a circuit. So we will understand it by drawing in a board and understand that. So let's come and see how we can show the VI characteristic, that is voltage current characteristic of a PN junction diode in the board. So VI characteristic, voltage and current characteristics. Voltage and current characteristics. VI characteristic of PN junction diode. So PN junction diode, if you will draw a PN junction diode, a voltage and current characteristic of a PN junction diode. The symbolic representation of diode is like this. So this is a PN junction diode, and this part is called as anode and this is called as cathode. So this is a PN junction diode, a symbolic representation of a PN junction diode. So whenever this diode is connected either in forward bias or in reverse bias. So what do you mean by forward bias? Now if you will connect a diode, if this is a diode and this is a anode part and this is cathode part, if you connect this anode part to the positive terminal of a battery and the cathode part to the negative terminal of a battery, then the diode is said to be forward bias. So positive and negative terminal. If the anode, this is anode and this is cathode, if the anode part of the diode is connected to positive terminal of a battery and cathode part of the cathode part of a diode is connected to negative terminal of a battery, then the diode is said to be forward biased. So this connection is forward bias, FOR, forward bias. Now if we will connect the anode in such a way that the anode part and cathode part, if you connect the anode part of a diode to negative terminal of a battery and cathode part of a terminal to a positive terminal of the battery, then the diode is said to be reverse bias. So this is said to be a reverse bias. REVERSE, reverse bias. So in this PN junction diode can be connected in a circuit in two ways. One is called as forward bias. So this is forward bias and another is reverse bias. In forward bias, as I told, a diode has two parts. One is this part is called as anode and this part is called cathode. If anode part is connected to the positive terminal of battery and cathode part is connected to the negative terminal of a battery, then the diode is said to be forward bias. And if in a diode, if anode part is connected to negative terminal of battery and cathode part is connected to positive terminal of a battery, then the diode is said to be reverse bias. Now in these two conditions, we can understand what is the VI characteristics of a diode in a circuit. What is voltage current characteristics? So let us study that. In order to study that, we have to draw a graph of x-axis and y-axis. So if this is a graph, this is a y-axis and again we will draw a x-axis. So the y-axis represent the forward current. Y-axis represents the forward current and x-axis represents the forward voltage in the right hand side, and in the left hand side the x-axis represents the reverse voltage and y-axis represents the reverse current. So we have drawn a graphical representation of y-axis and x-axis, and x-axis is representing in right hand side, the x-axis is representing the forward voltage and forward current, and the left hand side is representing the reverse voltage, reverse current and reverse voltage. Reverse current and reverse voltage. So this is the graphical representation of to show the VI characteristics of a PN junction diode. Now let us consider in a forward bias, when the diode is connected in a circuit in a forward bias, how the VI characteristics, how we can show the relation between voltage and current characteristic of a diode when it is connected in a forward bias. So we will understand that. So when the diode is connected in forward bias, as the voltage, as there is a voltage up, we will apply a voltage across the terminals of anode and cathode of a diode. How it will happen? Now the 0 here, the point is 0. Slowly we will increase the voltage. As we increase the voltage, the conduction of a diode begins here slowly. It will increase and slowly rises up. So it will rise up in a certain voltage. The current rises up. So this voltage is called as peak voltage. This voltage is called as peak voltage. So as from 0, slowly we will increase the voltage 1 or 2 volt. Slowly, as we increase the voltage, a certain point the current flow in a maximum output will come. So this voltage is called as peak voltage, at which the current will flow maximum through the diode. So this is the VI characteristics. So slowly, as we apply the voltage, the current slowly increases, and as soon as it reaches a peak voltage, maximum currents flow. And in the case of reverse bias, what happens? Whenever we connect the diode in a reverse bias, we know that in reverse bias, diode does not conduct, but there is a residual current which is flowing through the diode when it is connected to the reverse bias. So we will represent that whenever a voltage is applied. So this is IR and this is VR. A certain voltage is applied, there is a little bit residual current. So the graph begins here, and here there is no change. Here there is no change in the current. Sorry. Now we can take other color here. Red color I will take. So in reverse bias, there is no change in current. As we increase the voltage, but the current remains the same. But as soon as we reach a certain reverse breakdown voltage, the maximum current flows. So this point is called as reverse breakdown voltage. This point is called as reverse breakdown voltage. So this point is called as reverse breakdown voltage. So now we understood that VI characteristic means voltage current characteristic of a PN junction diode. A diode has two terminal, anode and cathode. So diode can be connected in a circuit in two ways, that is forward bias and in reverse bias. In forward bias, what we will do, we will connect the anode terminal of a diode to a positive terminal of a battery and cathode terminal of a diode to the negative terminal of a battery. Anode is always considered a positive and cathode is considered as a negative. When we connect the positive terminal, that is anode part of a battery, to positive terminal of a battery and a cathode terminal of diode to negative terminal of the battery, then the diode is said to be forward bias. And in reverse condition, the anode part of diode is connected to the negative terminal of a battery and cathode part of a diode is connected to positive terminal of battery, and this condition we will call it as reverse bias. In forward bias, the diode conducts. In reverse bias, the diode does not conduct. So in forward bias, when diode is in a conduction mode, how the VI characteristic represent? So to represent that, we have drawn a y-axis and x-axis graph. In x-axis we have taken a voltage, in y-axis we have taken current, and in y-axis we will represent as in a forward bias, so we will represent the forward current, and in a forward bias we will represent x as the forward voltage. So as we slowly increase the voltage, so what happens, the current slowly increases, and at a certain peak voltage the maximum current starts to flow through the diode. So this voltage is called as a peak voltage. So this is the VI characteristic of a forward biased current, that it starts from 0 voltage. Slowly, as you increase the voltage, the current increases in the diode, but as soon as it reaches a peak voltage, the maximum current starts to flow through the diode. So this is the VI characteristic of forward bias current. And in a reverse bias condition, what happens, even though this diode is connected in a reverse bias, a residual current is flowing through this diode. So we will take IR a little bit down, because the residual current is flowing even though it is connected in reverse bias. So we will take it down, and at a certain point the voltage, the current does not change even though we are increasing the voltage. We are increasing the voltage in x-axis line. Even though we are increasing the voltage, the current remains the same. So see here, the point, it is remaining the same. But at certain reverse breakdown voltage, at certain value of voltage, the diode breaks down, and reverse breakdown voltage, the current, maximum current starts to flow from the diode even when it is connected in reverse bias, when the voltage is increased to a certain level. So this point is called as reverse breakdown voltage. So now we understood the VI characteristic, voltage characteristic of a diode in both the condition, that is forward bias and in a reverse bias. So this diagram is not so clear, but we can understand it easily. Nothing, we have to draw x-axis and y-axis, axis and y-axis. In y-axis we will represent a forward current, and in below the y-axis we will represent a reverse current, and in x-axis a forward voltage and reverse voltage. So slowly the current increases. When in a forward bias we increase the voltage at certain level, the peak voltage, the maximum current starts to flow, and in reverse condition, even though it is in reverse, residual current flows. So we will take a little bit down here. Again, the current remains same even though we are increasing the voltage, and as soon as it reaches a certain voltage, which is called as a reverse breakdown voltage, maximum current starts to flow. So this is the VI characteristic of a PN junction diode. So diode is nothing but when a p-type semiconductor is joined electronically with n-type semiconductor, PN junction diode is formed. So either we can make it through germanium or silicon, this semiconductor. So today's class is this much. Next we will meet with some more knowledge. So we will be back with some more knowledgeable video in next section. Till then, have a nice day. If you like this video, please subscribe the channel and even press the bell icon, so that the whenever I'll make the video regarding these semiconductor or other chapters of physics for NEET and PUC first, second or 10th standard, you will get the notification if you press the bell icon and subscribe the channel. So if you like, and I hope you will subscribe the channel and press the bell icon so that you will get the notification regarding the chapters which I make, and I am making other videos, motivational videos also. You will get that. Till then, have a nice day.